Hi Year 11, this is the first video on logarithms. So if we have a function f of x equals a to the power of x, so an exponential function, then the inverse of that is actually log with the base a, x, where a has to be greater than 0 and a cannot equal 1. Some properties of a log function: x equals 0 is an asymptote, the curve crosses the x-axis at 1, 0, the domain is all positive real numbers, and the range is all real numbers. This first formula here is on your formula booklet. So log ab equals x is the same as a to the power of x equals b. So that rule there of interchanging between a log and an exponential is quite important, and it does come up fairly often in questions. But as I said, it is also in your formula booklet. Log AA equals 1, so if you have the log to a base a of the same value a, just equals 1. Log a to the power of x, just equals x. A note here, log 10a is the same as just log a, so often you'll see log just written without a base value. If it's like that, then it is assumed it is a base of 10. So on your calculators, when you see a log button, it sometimes may not have a base there, and it will mean a 10 base. We also have natural logs, which is an exponential. So log with a base of ex is exactly the same as lnx. And we often use lnx as the notation rather than log base e. And once again, on your calculators, you'll see you have a log button and you also have an ln button. With these and the inverses, so ln e to the power of x is just x. The ln and e are inverse, so they kind of cancel each other out like a multiply and divide. And e to the power of ln x, once again, just equals x. The e and the ln cancel each other out. Example here. So we have a function f of x equals log base 10 of x minus 2 plus 1. Part A, describe the transformations necessary to transform the graph of g of x equals log 10x onto f. So what do we need to go from a normal log function of log base 10x into what the f of x is there? So this plus 1 at the end, we know when we add a number to the end of a function, it translates the graph up by 1. So we know that that will give us a vertical translation of 1 unit up. Now when we have a minus 2 next to the x, that's a horizontal translation. And it's a minus 2, which means it's going to be going to the right. Part B, write down the equation of the asymptote of f. So if we scroll back up, we see here x equals 0 is a vertical asymptote. So that vertical asymptote is going to move by 2 units because the minus 2 moves that vertical asymptote 2 units along to the right, which means that asymptote will now be at when x equals 2. Find the domain and range. As the asymptote is when x equals 2, it means for our domain, x must be greater than 2. And our range is going to be all real values. So if you think about it, very similar to exponential, but the opposite. Part D, sketch y equals f of x, so sketch the function and the line y equals x on the same graph, and then sketch your inverse. So here's one I prepared earlier. So the green line is the function f of x, which was given in the question, the log base 10 of x minus 2 plus 1. Then the pink line is the inverse of that, so that will be the graph of the exponential. We know that's what an exponential graph looks like from last week's lessons. Okay, example 2. Got a few here just to work through. So A, write log base 7x equals 2 in exponential form. So that's just using this equation here of just converting between one and the other. What we'll do is we'll write that down here, and we're just going to use this to help with this question. So log 7x equals 2, and we're just going to use that straight conversion. That will be the same as 7 to the power of 2 equals x. Part B, write x equals the square root of 8 in log form. So the first thing with this, what we would want to do is write it without the square root, so it'll be 8 to the power of a half. And now we're just doing what we did before, but the opposite, we're going in the opposite direction. So 8 is the base. We will have log 8x equals a half. Part C, find the value of log 2 32. So first of all, I'm going to write this out. So we're going to have log 2 32. We want to find out what that equals, which we're going to say is x. Put this into exponential form, so 2 to the power of x equals 32. We can write 32 with the base of 2, so it would be 2 to the power of 5, so x equals 5. Part D. Solve for x in log 3x equals 5. Convert it to exponential form, so it'll be 3 to the power of 5 equals x. Put that into your calculator and you'll find that x equals 243. E, we want to simplify ln e to the power of 3. Now remember, ln and e cancel each other out, they're the inverse, which means that just equals 3. Then F, solve for x in ln x equals 2.17. So this is a log, so we can then convert it to an exponential. So remember, this is the same as log e x equals 2.17. So this would equal e to the power of 2.17 equals x. And then we can put that into our calculators, which would mean that x would equal 8.76, the three significant figures. And that is the start and basics of logarithms.